Yeah, now I joined even in YouTube also. Okay, good. In the previous class, I think we started circular motion. Am I right? I think. Yes, correct. Yeah. In circular motion, what are the things to, yes. What are the things to be discussed here? Okay. Yes, come to here. The things to be discussed. First, we go through the circular motion, Anna. Here, the things to be discussed, number one by one. I am going to tell here. And here, try to remember those physical quantities till I complete the rotatory motion chapter. Okay, good. Then here, who is this press wall? Okay, right. Good afternoon. Suppose this is one circle here. I am going to draw. This is a circle. Yeah. One by one, I will come into the circular motion. Right? First, in the circular motion, what are the things to be remembered, sir, to derive the centripetal force? Okay, Nana, Esther. So here the things to be remembered. Number one, suppose a particle is in the circular motion of radius capital R or smaller. And here, suppose that particle starts from A moving with a constant speed, not velocity, speed. And I'm taking that speed is either constant or variable. Okay, first it is moving with a speed V and goes from A to another point, point B. To here in a time, say suppose some dt is the time taken. To move from where to where? No need to ask. To move from happily A to B. Okay, now when it moves, where it is moving? On the circumference. Okay, on the circumference, while moving from A to B, look at the radius Badudhai is making an angle at the center. Am I right? That angle Badudhai, we call him in mathematics as angle only. Okay, but when you come to physics, the same angle, here we are giving a good name to him, Namakarana Mahotsavam. Here we are giving the name to it. For whom? The known angle in mathematics, theta, in our physics, is called the angular displacement. Oh, angle in mathematics is nothing but angular displacement in physics. Yes, this is the angular displacement. Usually, yes. In actually mathematics, we measure this angle most of the time with the degrees, like 30 degrees, 45 degrees, we say. Of course, sometimes when the sharads are cold, then we say here, this is sorry, sir, pi by 6 radians, sir. This is pi by 4 radians, sir. Correct, Anana? Yes, right, correct. Sometimes we say in radians, yes. So there in mathematics, here you measure in degrees or radians, no farak. Okay, both are almost the same. But in physics, Okay, this is physics, not mathematics, to accept anything. Okay, in physics, we measure, it is measured only in radians. Keep in mind, it is measured in not degrees. We are not accepting the unit degrees, measured in radians only. Okay, even in numericals also, don't substitute theta is equals to, suppose given 30 degrees, don't substitute 30, substitute pi by 6. Now I think you understood numerical problem here. Right. If it is 120 degrees, don't substitute 120, substitute 2 pi by 3. Okay, good, right. So I think you understood. Yeah, 2 pi by 3. Yes, yes, yes. So here our unit is not degrees, it is radians. Okay, right. This is very simple thing, sir. It moves from A to B. Obviously, it is makes some angle at the center. You ask further. The other things also we say very easily. What, Ranana? We are expecting that you are going to ask the sector principle. Ah, very smart boy. Yes, exactly. You read my mind. Okay, not my body. Here, my mind. So here, very good. I'm going to ask the same question. What is the sector principle? According to the sector principle, here, I think all of you remember in your lowest standards, sector principle is angle made at the center of the sector equals to arc length divided by, anyone remember, Nana? 2 pi r into 360 degrees. Is it correct? What? Yeah. That is area kada Nana. Easter 2 pi r kada. Pi r square 2 pi r. Right. So arc length by 2 pi r into 360. Yeah, exactly. This one, what you learned in your lower standards. Yes. Easter only, Nana, that you told Lakshmi Gayatri. Sorry, Easter only. Easter only, na? Easter. Okay. Okay. Sorry. Right, then here, theta is equal to arc length by, ayyo. Very sorry. Better I call her as an angel. This is better. Okay, don't feel bad, Nana. I am calling you from now onwards angel. Okay, na? Right. Yes. Thank you. Theta is equals to arc by length into 360. Right. Then here 2 pi and 360 are equal now. Then you can cancel and you may write it as, yes. Theta is equals to arc length. Let it be L by R. Okay, very good. Try to remember this formula, Nana. Okay, from this, I'm going to write here, yes, our useful formula, L is equals to R theta. Okay, the arc length AB is equals to R into theta. Then in what way it is useful? Actually, this is a sector principle in mathematics, sir. In what way you are going to use in your physics? Yeah, here in my physics, I'm going to use it like, suppose the arc length is small, means almost up to here. If I take the point B here, then obviously it will be the small sector. If it is the small sector, the arc length is appear to be a straight line. If I measure a length in a straight line, I have to call it, by following the norms and rules, it as a displacement. Am I right? The length, yeah, the length measured in a straight line is called as displacement. That's why what I am going to say here, if this length is small, if L is small, then the arc length is defined as, I better write here, is defined as the displacement, linear displacement. Displacement. Now look at here, all of you know displacement is a vector. Radius also, I say it is a vector. Then you may ask, sir, radius vectorings are nonsense. Okay, means you are saying that radius has no direction. Yes, sir. I think you are wrong, not I am. In what way, sir? Radius means generally you measure, you measure the length from center to perimeter or perimeter to center. Radius means center to perimeter, na? Am I right, Nana? Yeah, center to perimeter means you are giving, a specific direction. You are saying the direction means obviously radius is a vector. Yes, sir. Okay, agreed, sir. Right. Okay, thumbs up, sir. Agree. Okay, define. Here, Here, radius is also a vector. Displacement is a vector. Yeah, thank you, Lakshmi sir. Displacement is a vector. Radius is a vector. What about theta? Theta vector, and sir. Abba, theta, if it is not a vector, why you agreed? You already you agreed and wrote a document to Sharas sir. The anti-clockwise angle is taken as a positive and clockwise angle is taken as a negative. Yes, that's what I'm saying. Excuse me. Opposite direction, you are taking it as a negative means you are considering the direction. So obviously you already agreed with Sharas sir. The angle is a vector. Okay, am I right, Nana? Otherwise, how you take here like this in your mathematics? Yes, anti-clock positive, clock negative. Okay, so here theta is also a vector. Angle means in our physics, oh sorry, I should not call it as angle. We gave a name to it now, angular displacement. Angular displacement, new name we gave. Okay, this is theta is a vector. Oh, in this equation, okay, all are vectors. L, displacement, vector. R, radius, a vector. Theta, okay, now our eyes are opened widely. It is also a vector, not a scalar. So all our vectors means here I have to take according to our rules in multiplication to get a vector, scalar product or vector product means a dot or cross to get a vector on the other side. Cross is a vector product. That is not scalar product. Okay, na? Cross product is a vector product, na? Am I right? Yeah. Right. Good. Then here we take this one, what L bar vector form is equals to R bar cross theta bar or theta bar cross R bar. Okay, any one I have to write. Cross product dangerous one. It is a vector. If you don't write it in a proper way, you will get opposite direction. That is a big problem here. Abba, what is this, sir? Okay, don't get scared when I am here. Okay, I'm here to explain. Why are you bothering and worrying here? Look at It is moving in anti-clockwise direction or clockwise direction according to the given specific direction. Anti-clock, no? Yes, yes, yeah. Thank you, Aditya. Anti-clockwise. So in the anti-clockwise direction, at this point, draw a tangent. It is the direction of displacement. Yes, bar. Consider this is along x-axis. X-axis means that I write it as SI cap. Is it correct, Nana? Vector form? Yes. Good. Now, at the same point, look at the radius, fellow. Yes, thank you, Deepali. Yeah, finally you gave the symbol. Right, thank you. Here, the radius vector. Look at here. This is minus j. Mr. Ramo quickly responded. Good. This is radius vector. It is r bar, which is equals to r into minus j. Very good. So displacement and radius are over. Okay. Means here I should get the displacement is I cap is equals to other side. Already I know r is here minus j. Okay. And number three, angle. Okay. Angle here. I think you know in our mathematics angle direction we measure it with the right hand thumb rule. Right hand thumb rule means we put the rolled all the four fingers here like this. These right. Yes. In physics only. Very good. Yeah. Four rolled fingers we place on the plane and in the direction of the rotation of this body anti-clockwise. If I place four fingers, rolled fingers, curled fingers in the direction of this anti-clockwise, you will get the thumb. Yeah, thank you, Nana. 10th class. Okay. Right. Outwards or inwards? Means upwards or downwards? Out or in? Manikanta, look properly. Right. Good. Means out of the plane of this board. Okay. Yes. Out. Out means theta. I am getting here. Theta bar is equals to theta into outwards in your three dimensions of mathematics. I take it as plus k cap. I think you know it. Outwards is plus k cap. Inwards is minus k cap. Yes. Good. So this is theta k cap. Yes, very good, Nana. So I should get I cap, Nana, by taking the cross product of these two. Okay, I'm just checking whether r cross theta is correct or theta cross r is correct. First, I'm writing r cross theta. R, that is minus j cap cross theta. This is k cap. Minus j cross k, how much you get, Nana? Minus I cap or plus I cap? Yes, very good. This is minus I cap. But here I should get plus I cap. Plus I cap means I think this is absolutely wrong. Correct, Anana? Yes. That's why here no need to check the other. Directly I write L bar here is equals to not r cross theta. This is theta cross r. Now all of you understood my explanation, Nana? Yeah, thank you, Nana Deepali. All of you understood my explanation? Yes, sir. Thank you. Yes. Thank you, Nana. Right, good. K, oi, Lakshmi Gayatri, K is along x-axis, K cap is along z-axis. Yeah. Along z-axis, Nana. Yes. Then what's your doubt here? Oh, okay, right, good. So nothing, right. L bar is equals to all of you understood? Theta cross r, not r cross theta. I already proved here. Okay, right. So I am going to just erase this part. This I will keep it there for checking while writing the notes. This is just for cross checking. Okay, good. And here, formula in vector form, formula in scalar form, both over nana. This is scalar form, means magnitude. And this is the vector form. Means this is actually mod L bar. Okay, is equals to R into theta. So about the displacement, we completed one concept here. This is all about displacement and angular displacement. Linear displacement, angular displacement, theta, how they are interrelated. Here I explain. Okay, Nana? Good. Next. Yeah. Suppose this theta is while moving, all of you, I think you can easily understand. If I give more time, it will complete more angle at the center, Kadanana. Yes. Means with the increase of time, the angle made at the center also increasing. Okay. While the theta is changing, immediately we measure what will be the rate of change. Okay, means I am writing here the rate of, the rate of change of angular displacement. Okay, is called, just to follow the logic, Nana, rate of change of displacement is velocity. So rate of change of angular displacement, yeah, exactly, that word only I'm going to use. Yes, yeah, not angular momentum. Rate of change of displacement is velocity. So angular displacement will be angular velocity, na? Am I right? Lakshmi Gayatri? Yeah. Angular displacement. Yes, correct. Is called as angular displacement. Simple. Sorry, angular velocity. Okay. Oh, second new fellow today I'm going to introduce. First new fellow, angular displacement. Okay. Second new fellow, angular velocity. Okay. These are all new physical quantities in this chapter. Okay. And sir, will you represent this one with a letter? Good afternoon, Anna Ishan. What is this, Ishan? We missed a lot till now. Omega, Tanisha, correct. Okay. I felt very bad, you know. Okay. Without Ishan, I told almost 25 minutes of class. Yes. Oh, right. Angular velocity, right. Good. So here, this is angular velocity. And this angular velocity, what Amok typed here? Okay, Nana. Good. This is first page only, no problem. Angular velocity, Amok wrote here v by, from there. Yeah, you are right, Nana. The relation you told Mr. Amok, you are right. Okay, that is correct. And here, this one from the definition, I write like this. That implies omega equals to rate of, means differentiation, d by dt, rate of change of what? Angular displacement. Angular displacement is theta. So according to definition, shall I write like this? Any mistake here, Rana? Yeah, d theta by dt. Yes, that only I wrote here. Correct. Very good. Very. From this, I think you can say the unit of angular velocity. Is it degrees per second or radian per second? Very good. Don't say degree per second. This is radian per second. Right. Angle radian by time second. Radian per second. Very good. Okay. This is the angular velocity. And by differentiating this equation in circular motion, Amog told one formula. Already he typed papam there. Okay, we are going to get that equation. What is that, sir? Here, second one, what I'm going to write. as we know, L bar equals to theta bar cross R bar. Okay. dl bar by dt equals to, I have to write differentiating d by dt of L bar is theta bar cross R bar. Luckily, in circular motion, radius is a constant. So happily, I can write it as d theta bar by dt cross R bar. Okay, since it is a constant. Okay, this is dl bar by dt, Nana. dl, L is displacement. Displacement by time, all of you know velocity. d theta by dt, just now in the previous page I told it is omega. So I am getting here, yeah, that formula only, Nana. Angel, I am writing. Omega bar cross R bar. Vector form you told, that's it. Okay, this is the, sorry, scalar form, vector form, you told the scalar form. Okay, it is the vector form, yeah, magnitude, yes, that implies V is equals to R omega. Yes, this is the scalar form, right? So here likewise, again I am writing, it is the vector form. And it is simple scalar form without considering the directions. It is scalar form. Okay, there I think I wrote both scalar, yeah, in scalar form and in vector form. Yeah, correct. There I mentioned, no problem. This is the angular velocity concept, Anna. Okay, in this angular velocity here, by differentiating whom you are getting the angular velocity theta kadanana, by differentiating theta. Yes, yes. That's why what is the direction of theta? That is the direction of omega. Am I right? And you said theta direction is measured with anti-clockwise or clockwise, right hand thumb rule. So omega also I have to measure with whom? Right hand thumb rule or not? Okay. Yes, yes. Thank you, Manikanta. Thank you, Deepali. Okay, thank you, Angel. Oh, right. Thank you. So here I say the theta and omega both are in the same direction. Okay, later I will write while completing the class. Yeah. Lakshmi Gayatri adds it does not have independent direction. Who Nana Lakshmi Gayatri? Angle and angular displacement. What you typed here, I did not follow, Nana Lakshmi Gayatri. Something you asked, but I did not follow. Will you say it again? Okay, in the meanwhile, she will type. And then here I am going to next one. If theta is changed, R omega, na, here R omega is the scalar form, Gadana. Originally, its vector form is omega bar cross R bar, kada. Now you understood? Omega bar cross R bar, and that one we write here as R omega when these two are perpendicular to each other. Keep in mind. Why? Because A bar cross B bar magnitude is equals to, we write AB sine theta. When theta equals to 90, that equals to AB, now we write. Between A and B. Right. In the same way here, I wrote V is equals to R omega, means R and omega are perpendicular to each other. That's actually I tried to explain here. R is along y-axis now. Theta is always in what direction? Z-axis. or here along y-axis, or simply r is in the plane and theta is perpendicular to the plane? They are always perpendicular to each other or not? Good, good, good. I think no need to explain. Now you understood. Right. That's why instead of r omega sine theta, I wrote it as r omega, simple. Okay. Why? Because always the angle between r and omega is 90 degrees. Good. It is a scalar form. And here, what I am trying to say, actually, when theta changes, rate of change of theta we wrote. In the same way, if omega changes, I have to say rate of change of omega. That one I am going to write here. Okay, the rate of change of angular velocity. Okay, is called rate of change of velocity is acceleration. So rate of change of angular velocity will be, I think, angular acceleration. Yeah, good. Angular acceleration. That's it. Rate of change of velocity is acceleration. Rate of change of angular velocity is angular acceleration. Yeah, good, good, good. Again, this one I have to represent with one letter. That is represented with the letter alpha. Okay. Yes. That alpha here, first form I write according to the definition. Rate of change of, that is d by dt. Yeah, very good. Correct, Tanisha. Yeah, correct. Yeah, Amol, your equation is also correct. Right, good. D omega, angular velocity. Rate of change of angular velocity is angular acceleration. Okay, I think all of you following. Why? Because they are simple definitions. Alpha is equals to d omega by dt. Yes. And again, what Amok did, differentiated again this vector form. Oh, we forgot writing the unit now. Yeah, Satvika, correct. Unit is a very good Amok. Radian per second omega by second. Don't cancel second and second. That becomes radian per second square. Good. Very good, very good. Radian per second square. Unit is. Okay, and the Amok told here this this v is equals to omega bar cross r bar. By differentiating, again we will get, as we know, in the same way. If I write here v bar is equals to omega bar cross r bar, and again differentiating in the same way. Quickly I try to finish now. Dv bar by dt is equals to d by dt of v bar is omega bar cross r bar. Again, in a circle, r is a constant, so we are taking it out, r bar taken out, and differentiating the other one, d omega bar by dt. This one alpha bar. So alpha bar cross r bar is equals to dv bar by dt is acceleration, a bar. Yes, Tanisha. Scalar form I am writing here. A is equals to r alpha. Actually, sine theta I have to write. Again, alpha will come in the direction of omega. Why? Because alpha is equal to d omega by dt. Omega is in the direction of theta. So finally, what I am going to write one by one. I am getting here theta. Omega depends upon theta and alpha. This depends upon omega. All the three, yes, all the three are in the same direction. Any wrong I wrote Nana here? Or else better I write or along the same line. Yes. Thank you, Nana. Or along the same line. And Undoubtedly, I say here for a circular motion using the right hand thumb rule, the thumb always perpendicular to the rolled fingers means the direction of theta is always perpendicular to the circular motion. Is it correct? Always, no second. Yes, correct. Very good. That's why here they act. They act in a direction perpendicular to the plane of circle. Okay, plane of circle. That's what I told. Here also confidently I say Lakshmi Gayatri. R is in the plane of circle radius. Alpha is perpendicular to the plane of circle. Again, the theta between them 90 degrees. So straight away I can say right here A is equals to R alpha. Okay, without second thought. Okay, so here again, this Badudhai is vector form and the later Badudhai is scalar form. Okay, this is brief introduction to the main physical quantities which are required to explain the circular motion. Okay, now it is the time to, of course, leave the class. Okay, Nana? Thank you, thank you. Do you want any pages? Today we have, unfortunately, only 2 pages. Thank you, Nana. Thank you. Who is this? This is first year. First year class only. Right. Page 1. And this is page 2. Oh, sorry, Ishan. Extremely sorry. Oh, Ramaditya. This is for first year's, Nana, Ramaditya. First year's class. Bye, Nana. Bye, everyone. Okay. This is first year's class.